Let me welcome you to the fourth lecture of surface mining technology. This is also the introduction to surface mining part. The today's lecture is the second lecture on the stripping ratio and pit layouts. We have already discussed as per our requirement the learning background for the course surface mining technology. This is the learning objective of the surface mining technology course, and this is the learning outcomes of the surface mining technology course. This is the continuation of the same, and these are the different textbooks and reference books. Now, let us retrospect what we have discussed in the previous lecture. In the previous lecture, we have discussed already in the previous class also. We understand the current scenario of surface mining worldwide. We understood in surface mining the main problem is the land acquisition, and that is very important. But surface mining is the main mining system. More than 90% of the minerals are being produced from the surface mining, and in last class also we are discussing with our relatively trying to understand that whether surface mining is possible for up to how much depth, or it can be economic for the deep seated deposit or not. So, those are we are in a little bit dilemma, and we will try to know whether the surface mining technology can be applied for the deep seated deposits or not. So, in this lecture our objectives are same as we mentioned in the last lecture also, to know the different terminologies related to surface mining, understand the importance of the stripping ratio. So far we have not discussed what is stripping ratio. In this lecture we will discuss it, what is stripping ratio, and to understand the basics of surface mining layouts, which we will discuss in the next lecture. So, this slide we have already discussed in the last class. In this slide we are discussing about the perspective of surface mining and underground mining, and we have found that there is no clear demarcation that up to this depth surface mining is possible, up to beyond this depth underground mining has to be carried out. So, this is basically a strategic decision, and this strategic decision should be taken with some economic considerations. So, surface mining is basically characterized, as we have seen as per our previous lectures, with high productivity. That means production per man shift is very high, mining cost is very low, the percentage extraction is very high because we do not keep any pillars for the supporting. So, whatever available ores are there, complete 100% excavation of the ores are possible in surface mines, and surface mine can be carried out with increased stripping ratio if we are having large mechanization. Now, this new term is there, stripping ratio. So, what is this stripping ratio? Let us try to understand. Stripping ratio is the term used for the volume of overburden to be removed to excavate a ton of mineral. So, that means whenever we have carried out underground mining, we need not to remove overburden, but in surface mining we have to remove overburden. Now, while we are comparing these two, we have to understand for taking out 1 ton of ore, how much waste rock or overburden rock is required to be excavated and taken out for getting that 1 ton of ore. So, this ratio is called stripping ratio. Now, if you look into this figure, you can see this is the ore which we need to excavate, and the total ore tonnage is B, but to take out this ore from here to outside, we have to excavate this portion of waste rock, which is basically the rock cap lying above this mineral, So, this rock cap is called overburden. Okay. So, this stripping ratio is the ratio of volume A, that is the volume of overburden, and the B, tonnage B, because the ore is in general expressed in ton. So, this is tonnage B, means the volume B multiplied with the density is basically giving us the weight B, that is called tonnage. So, this stripping ratio is the volume of overburden divided by the tonnage of ore, that is called stripping ratio. So, in other words, to get 1 ton of material, how much volume of overburden has to be removed, that is called stripping ratio. Okay. So, this line is important, overburden is expressed in volume because it does not have any commercial value, but you have to find out an volume area where you need to accommodate that one. So, that is why overburden is expressed in volume, because you need to address that for removing and placing that in a particular place, that is why it is called volume here, and mineral is expressed in ton because it is sold in ton. Stripping ratio can be of different types. Let us discuss the different types of stripping ratio which is available. First is that incremental stripping ratio. Incremental stripping ratio means, suppose today you are having a mine position up to this. Now, your mine management has decided that to increase further depth of operation up to x, then what is the situation? So, if you are extending your operating depth from h to h plus x, in that case, by doing this you will generate an additional B1 tonnage of ore, but to get that one additionally you have to take out A1 volume of waste rock or overburden rock. So, this A1 by tonnage B1 is called incremental stripping ratio. And if you have carried out this and an incremental volume of A1 is removed and incremental tonnage of B1 is achieved, then your overall stripping ratio overall stripping ratio will become volume A plus volume A 1 divided by B 1. If you had some suppose you had some previously owned ore B here, okay. In that case your before this your stripping ratio was A by B, and then after an incremental excavation of depth x, your overall stripping ratio in that case will become A plus A 1 by B plus B 1. Okay. So, overall stripping ratio means at the end of the mine, the total overburden removed divided by total tonnage of ore excavated is called the overall stripping ratio. Okay. I think now it is clear to you. We are now just discussing about the different types of stripping ratios. So, you can understand the initial stripping ratio as we have discussed earlier. The initial stripping ratio is A 1 by B 1. So, this is A 1 by B 1 and incremental stripping ratio A 2 by B 2 and overall stripping ratio become A 1 plus A 2 by B 1 plus B 2 as we have discussed earlier. Now, let us see it in a different way. Say suppose our ore body is dipping at an angle alpha, d 0 is the sub outcrop depth, means the ore body is not exposed to the surface. If the over body is exposed to the surface, then it is called outcropped. Okay. If it is not exposed to the surface, it is called in situ. In that case, our depth up to which the overburden starting its occurrence, that is called sub outcrop depth. So, d 0 is the sub outcrop depth, overburden is dipping at an angle alpha and beta is the angle of stable slope bench. So, if you are having a slope bench angle of beta, then only your slope will remain stable, otherwise it may fall. So, that is why beta is the stable slope angle. Now, at the very beginning, when your overburden is having an area of A B G H, that means if your overburden is having an area of A B G H, your ore excavated is 0. Okay. You do not have any excavation, but after that if you excavate a T 0 thickness of the T 0 is the thickness of the ore body, that is the, and if you are go for a depth of excavation of D. Now, this is the depth of excavation of D. To have this depth of excavation D, you need to achieve, let me change the color of the pen, then you will excavate this much of ore body and for this you have to excavate this much of overburden. Okay. So, your pre-production stripping ratio was area ABGH by 0. So, its stripping ratio is become infinity here, but at excavation depth of D, your stripping ratio will become area. This is the waste rock excavation area and ore excavation area is BC FG. Okay. So, your pre-production stripping ratio was infinity and overall stripping ratio will become this one, we have already informed that, and the ore production is this much. And if you are going for an incremental depth of excavation this one, then your incremental or instantaneous stripping ratio will become IJEF, that means and ore excavation is this much EFCD. So, EFCD. So, this is the incremental or instantaneous stripping ratio. The next stripping ratio is mining stripping ratio. Mining stripping ratio is basically used for deploying the machineries. That means, the mine management is decided that in this month or maybe in this week or maybe in this shift also, this much of overburden has to be removed and this much of ore has to be removed. So, it is a particular planning which is carried out. So, it is the ratio of volume of waste removed to the tonnage of ore excavated over any particular period of mining operation. That means, it may be for a month, it may be for a week, it may be for a shift also. This is basically carried out for allocating the different machines, the population of the machines that is required for achieving the production. So, what is happening, say suppose in rainy season etc., if your demand is less, that time mine management will deploy more machineries to remove the overburden rocks and they reduce the excavation of the ore. So, that time your stripping ratio will become more, and if you are in other dry time, if you are excavating ore mainly and reduce the excavation of the ore a lot, in that case your stripping ratio will be decreased a lot. So, this is depending on the demand and depending on the machine deployment it is carried out. So, that is called overburden, that is called mining stripping ratio. There is another term which is used, is called stripping index. It is the instantaneous stripping ratio divided by the grade of ore expressed in percentage, that is called stripping index. And the economic stripping ratio, it is clearly a maximum value of stripping ratio which should not be exceeded by this maximum value. This value is defined as the economic stripping ratio. So, the ratio gives up to which ratio we can go for mining with profit. So, it is dependent on a number of factors like labor rate, mechanization etc. The most important stripping ratio is named as the break even stripping ratio. Break even stripping ratio is defined as the profit per ton of ore minus the open cast mining cost per ton of ore divided by the stripping cost, open cast stripping cost of overburden for per ton of ore. That means, if you have to, the stripping ratio is basically gives us the overburden quantity required to be excavated for tonnage of ore. So, break even stripping ratio is basically the economic term. It is giving us the profit we are getting by selling 1 ton of ore. From here we are deducting the cost of excavation of 1 ton of ore. So, the remaining amount what is lying with us, we are checking whether that cost is, that amount is sufficient for excavating the overburden. This is overburden. So, overburden, that quantity of overburden which is required to excavate 1 ton of ore. So, if the stripping ratio is 1.5 meter cube per ton, then this overburden quantity is 1.5 meter cube. So, the cost of overburden removal for per ton of ore means the cost of removal of 1.5 meter cube overburden. So, this ratio is called break even stripping ratio, and in no condition you will allow the break even stripping ratio to go beyond, go less than 1, okay, below 1. So, that if it is 1 less than 1, that means your overburden removal cost is becoming higher than the amount lying with you after the selling of the ore. So, that is not allowed because it will not fetch you any profit. So, for that let us take one small example here. Suppose the price of the ore is 2 rupees, the cost of excavation of ore is means 2 unit, you do not consider it is 2 rupees, this is 0.3 unit. Then your, if the stripping cost is, your stripping cost of waste for 1 ton of material is 0.35 unit, then your break even stripping ratio is 4.86 is to 1. So, 2 minus 0.3 divided by 0.35. So, it is coming this value. Now, what it is showing, that means it is showing if our stripping ratio is further increased, then also our open cast mining will remain in profit unless and until we are having the stripping ratio increasing for more than this value. So, if our stripping ratio is increasing more than 4.86, then only our mining of with surface mining technology will no more remain profitable to us. So, that is why break even stripping ratio is very important aspect for decision making about the whether mining to be continue or not. So, now let us consider one problem in this. Say, consider a mine working with 0.5% copper ore with overall recovery of copper of 80% after milling and refining. If the price of the copper is 700 rupees per kg and the mining, milling and refining costs are rupees 200, and rupees 150 per ton of ROM. Now, let me explain you ROM. ROM means run of mines. A ROM means a run of mines. That means whatever this material is taken out from the mine, that is called run of mines, that the direct output achieved from the mine is called run of mines. So, the cost of mining is rupees 200, that means to take out 1 ton of run of mines is rupees 200. The treating of 1 ton of run of mines is rupees 200. The treating cost of 1 ton of run of mines, refining cost of that is rupees 150. That means, suppose run of mine is 1 ton, from here you are getting some portion, say 0.8 ton may be coming to the mill, and then the output of the mill, that 0.8 ton is then subjected to refinery, then that cost is basically considered here. If the waste handling cost is rupees 250 per meter cube, find out the break even stripping ratio for a mining stripping ratio of 4:1. So, if it is the 4:1 is the mining stripping ratio, let us find out whether it is remain profitable or not. So, let us find out, to solve this, let us find out what is the profit. Profit is that from 1 ton of run of mines, 0.5% copper we are getting. That copper actually we are selling, not 0.5%, 0.5% is the grade, but 80% is the recovery. So, 0.5 into 0.8. So, that much copper we are getting from the treating and milling and refining of the copper ore. That price is 1700 rupees per kg, and as we are considering the ton, so we are multiplying it with the 1000 to make it ton. So, this is the price we are getting, and we are subtracting mining price, milling price, refining price. Okay. So, by this one we have found our profit is coming 2250 rupees, and our waste handling cost is 250 rupees per meter cube. So, the 4:1 if it is the mining stripping ratio. So, 4 meter cube of overburden has to be handled for to get 1 ton of run of mines, that means the copper ore. So, to remove 4 meter cube of waste rock, we have to spend 1000 rupees. So, that means profit is 2250, waste handling cost is 1000 rupees. So, BESR is 2250 divided by 1000, so 2.25. So, that means it is further, it is still profitable, we can carry on mining. But you just think, if instead of mining stripping ratio of this one, if it mining stripping ratio is become 9, in that case this will become 2250, then our BESR will become, break even stripping ratio will become 1, and if it is more than 9, then BESR will become less than 1. So, it will, the mining will no more profitable in that case. So, above the stripping mining stripping ratio of more than 9, the mining will not become profitable. So, mining cannot be carried out in that case. The final one is the underground to open cast stripping ratio. This is the underground mining cost per ton of ore. This is the open cast mining cost per ton of ore divided by the open cast stripping cost of waste, which the for the per ton of ore. That means, here also you have to consider the mining stripping ratio. So, another problem is given here also for this. So, this is more or less about the stripping ratio. This topic will continue for the next class also. Thank you.